Hello everyone. So in this deeper dive video, what I wanted to do was to look at how to calculate the area of a more complicated geometric figure, like what's called a composite geometric figure. So in Module 10, we learned how to calculate the area of several different types of basic geometric shapes. So now we're going to sort of extend that just a little bit. So for example, let's say we have this figure which consists of, you can think of it as like a track. So you have two straight sections, and then at the ends we have like half of a circle. It's called a semicircle. So let's say it does that, and then over here it does that. And let's say we're told that this distance from here to here is 4, I'll just use feet. And then let's say that this distance, so from here to here, let's say that is 10 feet. Okay, and of course this is, on this side, this is another semicircle, right? Half of a circle. So what I want to do is I want to find the area of that entire shape there. In other words, I want to find what this value is, like this whole shaded area. Okay, so notice here, right, we can think of this as like 3 different figures. We have, I'll call this area 1. That's like half of a circle, right, semicircle. I have area 2. That's basically just a rectangle, right? This is area 2 here. And I have area 3, which is another semicircle. So can you see that if I want to know the total area, right, of this whole shaded region, I simply have to add area 1 plus area 2 plus area 3, right? So if I want to know the total area, I'll say total, then that's simply going to be area 1 plus area 2 plus area 3. Okay, so how do I find area? Let's start with area 1. Well, it's a semicircle, right? We know the area of a circle is pi r squared, and since it's half of that, I have to multiply that by half. So this is going to be half of the area of a circle, which is pi r squared. So in this case, remember this 4 here, right? This 4 really refers to the diameter, right, of that circle. So that means if the diameter is equal to 4 feet, that means the radius is half of the diameter. So that'll be 4 divided by 2, which is equal to 2 feet. Right? If the diameter is 4 feet, the radius is 2 feet. So when I plug into this equation now, I have 1/2. For pi, let's just use 3.14 is our estimate, right, in decimal form. And then our r is now 2, right, 2 feet squared. So if you multiply this out, if you want, you could write this as a decimal, right? 0.5 times 3.14 times 2 squared, which is 4. And if you work that out, it turns out it's going to be 6.28. And in the unit, since it's an area, it's going to be feet squared. Okay, what about A3? Well, let's do A3 first, and I'll go back to A2. A3 is the same thing, right? It's the other half of that circle, basically. So it has exactly the same formula. It's half the area of a circle. So this will be 1/2 times 3.14 times 2 squared. That also is going to be 6.28 square feet, right, or feet squared. And then finally, area 2. Well, area 2 is simply a rectangle. Right, we know how to find the area of a rectangle. It's length times width. Well, the length here we're given is 10, right? So the length is 10 and the width is 4, or vice versa, but typically you call the longer side the length. So length is 10 and the width is 4. So area 2, since it's a rectangle, is simply length times width. So that's going to be 10 feet times 4 feet, which is 40 feet squared. I'm being a little careless here, right? This is really feet, 10 feet, and I'm multiplying by 4 feet. And that's where the feet squared is coming from for the units of the answer here. I'm kind of skipping a few parts. I'm not putting in units everywhere. In this case, the units would go with the 2, right? But since it's squared, it's going to be 4 feet squared. So the total units at the end are going to be feet squared. So we just know since it's an area, the ultimate units will be feet squared. Okay, so I'm almost done. Now, how do I find the area of the entire shaded region? I simply add these together, right? So the area of the entire shaded region, A total, is going to be A1 plus A2 plus A3. So that'll be 6.28 feet squared. I'll just write that at the end. Plus 40 plus 6.28. And that equals 52.56 feet squared. Okay, so that would be the answer. That's the area of that shaded region. 52.56 feet squared. Okay, what if we have, let me give you a more complicated shape here. Let's say we want to find the area of this shape. Let's see, I want to make sure I draw this correctly. Okay, that's a straight line there. So let's say we're told, I'll give you all the dimensions now. Let's say this distance from here to here is 8 meters. Let's say this distance from here to here is 13 meters. And let's say if I went all the way down to the end, so if I go all the way to, let's dash it out here. Let's say if I go from there all the way to here, let's say that's 15 meters. Let's say this is 9 meters. And then we'll say that this is 11 meters. Okay, so I want to find the area of the shaded region, the area of this figure. So how do I do that? Well, you could try and break this up into, like maybe even trapezoids and rectangles, or you could break it up into triangles and rectangles. We could do that in this case if we wanted to. An easier way is the following. What if I do this? What if I consider this entire rectangle, the large rectangle, even though there's like a triangle cut out here, let's like ignore that for now. Let's find that, and then I'm going to ignore this triangle. So something like that. And if I look at that large rectangle, so this large rectangle now, I can find that area pretty easily, right? It's going to be, did I give you, oh, I need to give you one more piece of information here. You also have to know that this distance from here to here is 12 meters. Okay, so if I want to find the area of that huge rectangle, that's simply going to be length times width, right? So the length here, it looks like, is 15, right? The length is 15, and the width is 12. But if I calculate that area, I've overcounted, right? I've accidentally counted in this triangle, which I don't want, and I've calculated in this triangle, which I don't want. So why don't I find the area of these two triangles and then subtract them from the area of this huge rectangle, and then what's left is just the area of the shaded region, right? So let me do that in diagrams here. If I start with the huge rectangle, that area I can find. If I subtract the area of this upper triangle, upper left triangle, subtract that area, and if I subtract the area of the bottom right triangle, then what I have left must be the blue shaded region. Okay, so here let's find these areas. So this huge rectangle, remember this is going to be 15 meters and this is going to be 12 meters, right? So the area of that rectangle is length times width, which is 15 times 12. Well, that is equal to 180. So this is 180 meters squared. Then this little triangle. So we go up here. Basically, it's going to be this triangle right here, right, that I want to subtract. Well, if this total length is 12, and we know from here to here is 8, this must be what? It must be 4, right? Let me do that in green here. So this must be 4. And if we know that this total length is 15, and here to here is 11, then what's left over? Well, 15, if that whole thing is 15, and this is 11, then 15 minus 11 must be what's left over. So this is also 4, I guess, in this case, right? So this is also 4. Actually, let's figure out the other dimensions of this triangle now, too. So then we need this bottom right one. So again, if this is 15, and here to here is 13, this must be 2. And then if this is 12, right, from here to here, and from here to here is 9, this must be what's left over, which is 3. Okay, so this triangle is really, I didn't really draw it well, but this should be 4 and 4, and then this is going to be 2 and 3. And we know how to find the area of a triangle, right? It's 1/2. Let me do it in black. It's 1/2 base times height. So 1/2 base times height, or base times height divided by 2. So this is going to be 4 times 4 times 1/2, right? Divided by 2. So what's 4 times 4? That's 16 divided by 2. So this is going to be 8 meters squared. And in here, again, I have base times height over 2, or 1/2 base times height. So this is going to be 2 times 3 divided by 2, which is 3 meters squared. So I start with 180, then I need to subtract, right, the 8 meters squared, and then subtract the 3 meters squared. And what I have left over must be the shaded region. So 180 minus 8 minus 3. We can do this left to right. So 180 minus 8 is going to be 172. And then 172 minus 3 is 169. And it has units of meters squared. So that's the area, right, of that shaded region. It's 169 meters squared. So the other way you could have tried to do this is, create triangles and rectangles, and that would have worked too, but this is much easier. Find the area of the huge rectangle here, but then we've overcounted, so we need to subtract out that area, and what's left over must be the shaded region. Okay, let's do one more problem here. Okay, so in this problem, I have a piece of property, right? And on that property, there's a house and there's a pool. And I want to find just the area of the property, right? So basically the gray region, the shaded region. Okay, so how do I do that? Well, first of all, the property is not quite a rectangle. If you look out, there's sort of like a triangle that's kind of taken out here. So what we could do is we could kind of solve this the same way that we did the previous problem. I could find the area of that large rectangle. Let me extend this. Extend that. So I can find the area of the huge rectangle. Then I could subtract, since I've counted the house I don't want there, so I can subtract out that area. That's just a rectangle, so I know how to do that. I know how to find the area of a circle. I could subtract out the area of the pool, and I could subtract out the area of this triangle, and then what's left over must be the gray shaded region. Okay? So again, in terms of a diagram, I'm doing this, right? I'm starting with the huge rectangle. I'm subtracting out the area of the house. I'm subtracting out the area of the pool. and I'm subtracting out the area of that triangle. And then what's left over must be the gray shaded region. Okay, so what was the area of the entire property, including that triangle? Well, looks like the length is 150 and the height is, or the width is 120, right? So that would be the whole thing, including this triangle here. So 150 feet, and then this was 120. So what's the area of a rectangle? It's length times width. So this would be 150 times 120. Okay, whatever that is. It looks like I would just do this on the calculator. It looks like this is 18,000. Okay, then I have the area of the house. That's also a rectangle, right? And in this case, it looks like the length is 50 and the width is 30. So length times width, this is going to be 50 times 30. So that's 1,500. Right, this will be 1,500. By the way, this is really feet squared. Feet squared. But I'm subtracting that. Then I have the area of the circle. Well, what's an area of a circle? Well, we know it's pi r squared, right? So in this case, the radius we're told is 12 feet. So if I do pi r squared, that's going to be 3.14 times 12 squared. And when I subtract out the area again, so what is that? Let me just pull out my calculator and do this. So 3.14 times 12 squared. It looks like 452.16. This is feet squared. Minus, and then finally, what do I have left? I just have that triangle. So let's go back to the figure. Let's figure out what this dimensions are of that triangle. Well, let's see. If this whole thing, right, this whole length is 120, right, that whole side, I guess we're calling it the width, but it's the length of that entire side. And from here to here is 60. This must be just 60, right? That's what's left over. So this is 60 feet. And then if this entire length is 150 and this is 130, then we know this has to be 20, right? Because 130 plus 20 would give us the entire 150, right? So I can say 150 minus 130 is 20. So this is 20 feet. Okay, so the area of a triangle, so this again is 60 feet. This is 20 feet. It's base times height divided by 2, right? So this is going to be 20 times 60 divided by 2. And I guess that's, let's see, it looks like that's 600, right? 10 times 60, yeah, this is 600 feet squared. Okay, so now I just need to work this out, right? So I start with 18,000. Again, I'll go to my calculator. So 18,000 minus 1,500 minus 452.16 minus 600, and that's equal to 15,447.84. And this is feet squared. So that would be the area of the shaded region, right? The area of the property not including the pool and the house. That would be the answer. Okay, and you see that we can, very quickly solve just using our basic equations for the area of the geometric figures that we're familiar with, rectangles, triangles, circles, trapezoids. We can start to solve some very complex problems. Okay, great, thanks.